I am Anil Kumar. Welcome to my limited edition of physics. This series is meant for students like me who kind of got physics in school level and really felt need of understanding it better at university level. So we'll talk about kinematics. We'll cover only basic concepts in the first video and then look into more details. I'm going to cover up topics on mechanics, which includes kinematics and dynamics. We'll talk about scalar and vector quantities, concept of small change. Now this is very important criteria which we need to understand when we move on to velocity. Then what we really mean by one-dimensional displacement and velocity. With the help of an example, we'll kind of summarize what we have learned. So basically, we are only going to discuss about movement of an object. So the criteria here to understand movement of an object. Now, whenever there is a movement, it is a change in position. Now, this change is always with respect to time. So these are key things which gets linked with, right? Then how fast or slow it is. That brings into speed and velocity into consideration. So that is what we are going to look into as we move along, correct? We'll not look into the cause of movement, which will be covered in dynamics. And the question for you here is that if the object is not moving, can we consider that to be a movement, right? So that is an idea to think about. So let's move on and cover mechanics, the very basics, and understand its definition. Now let's understand what is mechanics and how kinematics and dynamics are related. So we just said that we'll talk about movement, right? Movement means change in position. And we say that to be in motion. So that is what the motion is for us, right? Now, if there is no change in motion or no change in position, that is also a motion. It is a very important concept, right? So change in position could be in any direction. Right? It could be in any direction. There may not be any change. Even then, we'll consider that to be a motion. So the branch of mechanics is related to understanding the motion itself and what causes or produces the motion and the effects of motion. So mechanics basically is study of motion, causes of motion, and effects of motion. So all these three things is what mechanics is all about, correct? So we'll have three different chapters on mechanics. The very first one, which is just the study of motion, is called kinematics. But soon when we will add these components, then it becomes dynamics. So that is the major difference between the two. So when we are just talking about change in motion, basically speed, distance, and time, velocities, displacement, and position, for example, it is kinematics. The components which gets added when we talk about dynamics is major component is force. So when we add force, we'll talk about Newton's laws, right? So force. So that is the major thing which gets added. It becomes dynamics. Force causes or changes motion, right? Now in kinematics, we'll limit ourselves to linear motion, right? So in this chapter, we'll limit ourselves to straight line, linear motion. Correct? So that's the whole idea. So let's move forward and understand few more concepts. Now, let me take an example of motion. Let us say we go from home to school. And let us say that this distance is 500 meters. And time taken to travel this distance is, let's say, 5 minutes. Now, that is kind of a motion which can be described with the help of kinematics. Now, one way to describe this is that the position changes from home to school, which are 500 meters apart. So that is the distance between them. Is it okay? We could also say that the speed during this time when I traveled from home to school was how much? We could say speed is distance covered over time taken, right? Taken time. Let me write it the other way. So in our case, distance covered is 500 meters and time taken is 5 minutes. So we could say that the speed is 100 meters per minute. Now, whenever we are talking about kinematics, physics specifically, we have to be very particular. So in this case, what we are really talking about is average speed. So let me qualify this word with average. So we say average speed or the overall speed of this journey was 100 meters per minute. That is one way of describing it. The other way is that we could say that the movement from home to school. Now we are given a direction. Do you see that? Direction is from home to school. So that is a major difference between what we talked about earlier and now what we're discussing. Now that leads to a different concept altogether. So when we add direction, it becomes a vector quantity. So here we did not talk about direction. We only referred to magnitude. Do you see that? So we say the magnitude So magnitude is 100 meters per minute. Do you realize that part? Now here we'll talk about direction also, and then we can actually rewrite all this and say the average speed, instead of average speed we'll say average velocity now, is equal to change in position . which is from home to school, right? Over change in time. So this change will refer to as mathematically we'll write as delta with a triangle, right? So let's say change in position is delta p over change in time, which is delta t. In our case, change in position is 500 meters and it is from home to school. So I'm just writing this arrow on the top indicating the direction home to school, and change in time is 5 minutes. So in our case, the average velocity, which happens to be a vector quantity, since we are talking about direction also, we'll write this in short as v, and to indicate that this is a vector quantity, I will write an arrow on the top. So I could also write this as v with just a bar. That will also represent vector for me. Or I could say v in bold. So these are different ways of writing. So for me, writing in bold will be difficult. I'll put this bar on the top with one arrow. So it becomes that the velocity, the average velocity, let me call v average, is 100 meters per minute, and the direction is from home to school. Some way will give the direction. So with that, you get an idea of how scalar vector quantities are related, how they should be written, and which quantities are scalar, which are vector, right? Now the question for you is, we had talked about distance and time. Now both these quantities are scalar, right? So scalar quantities for us will be distance and time. As far as the vector quantities are concerned, these will be, in our case, change in position is called displacement. And also speed, right? Speed is scalar. Now displacement and velocity. You also learn one more thing here, and that is that if you divide vector quantity with a scalar quantity, you get a vector. Do you see that? So we'll talk about this also at times. So displacement and velocity will be referred to as vectors. So these are examples of vectors. And these are examples of scalars, where we are only talking about magnitude. So I hope that part is clear. It is important to understand that change in time will be referred to as scalar. Time will be scalar. Okay. Distance, time and speed are scalar. Displacement and velocity will be treated as vector. So let's move on. So I hope this concept is clear. Now let me again take the same example, a journey from home to school. So let me show it on a graph. We kind of learned last time that it was a small distance of 500 meters in 5 minutes. And we found that the speed, let me write speed as such now, is 100 meters per minute. And speed is a vector quantity. Now let me graph this on xy plane. Let's say time is on the x-axis and we have position in y-axis, right? So we'll call this as position. So the journey of 500 meters which I took was kind of like this. I started off fast then kind of took a break, talked to my friend, and then reached the school. So what I'm trying to say here is that this distance of 500 meters was covered in 5 minutes. And the average speed was 100 meters per minute, right? So do you understand this concept of average speed? So let me qualify this word again with average speed. So I hope you got an idea of average speed means what. It is overall journey divided by the time taken for this journey, right? Now, in first part of this journey, you will notice that the speed was different. We covered more than half the distance in the first part itself, correct? So, which is, let us say, I didn't make any scale here, but anyway, let's say we write this as, let's say this is 4 and this is 3 for us, time in minutes, okay? So, and let's say that this distance here is 300 meters. Now the question for you is to find average speed in the first part, that means first 3 seconds, starting from home, which is here, school is there. So what we note here is that the average speed when the time is from 0 to 3 minutes, this is the time, right? Time equals to from 0 to 3 minutes. We covered a distance of 300 meters. Is how much? 300 divided by 3. It comes to 100 meters per minute. Now the average speed in time from 3 to 4, in time which is from 3 minutes to 4 minutes, the distance is still 300 meters, right? So the distance covered is 0. So we get 0 over 1 minute, which is 0 meters per minute. And the average speed when time is from 4 to 5 minutes, that means 1 minute, is the change in time. Change in distance is 200 meters. 500 minus 300 divided by 1, it is 200 meters per minute. So if we analyze our journey into smaller bits, we get more details about the whole journey. So we can now say that at this time, the speed was maximum. Kind of rushed to school. Here, it is stand still. As far as motion is concerned, you will say stationary, zero movement. Zero movement is part of our motion. It's very important to understand that part, right? And this is good start. Let's say slow. So we can give more details if we break down our journey into smaller bits, and that is how we come to this part of small change. Now the small change will be referred to with delta. So it could be a small change in time, or it could be a small change in any other thing, right? So a small change will be referred to as delta. So if I say delta t, it means small change in time. It means small change in time. So we'll actually get to a very important concept of delta t approaching 0. So that means delta t approaching 0. That means change in time approaching zero. It can never be zero, but it could approach. Now, when that happens, we will see how the average speed changes to instantaneous speed, right? So this will lead to a new term which we will call instantaneous speed. That is when the time changes are very, very small. So that is to say, when we are considering a small bit of time, in that case, the speed will be at that instance, and that will be referred to as instantaneous speed, speed at that instance. For a straight line, average and instantaneous speed is going to be same, right? So in this case, for smaller portions during any interval in a straight line, average and instantaneous speed will be same. However, we'll take up cases which are not linear. In those cases, average and instantaneous speed is going to be different. Okay. So what we learned here is a small concept of small changes. Small changes gives you more insight to the problem, understanding, and also if the change is very small, very, very small, approaching zero, we'll replace these terms, average, with instantaneous. If delta t approaches zero. Okay, so that is the concept which is very important to understand as we move along. Now let me highlight one more important concept which always confused me: one-dimensional displacement and velocity. So what I will take again is the same example, going from home to school. Let me just sketch what we did just now, something like this, right? So let's say something like this, where the whole journey of 500 meters takes place in 5 minutes. So we are saying this is distance in meters and this is time in minutes. So we kind of mark this as 3, 4, and then 5. Okay. So let's say this is position for home at 0, and that is the school. And this is home. Now, as you can see, this is two-dimensional, right? Coordinate plane has 2 dimensions, time and distance. Do you see that? So normally, we display the motion, display motion using 2 dimensions. Okay. Like you can see here, in this case, the 2 dimensions are time and distance d. Okay. But in all our questions, for simplicity, we talk about one-dimension displacement, linear and one-dimension, both. So what is one dimension? That is kind of a big question. So what we normally do is, only for simplicity, let me write here, only for simplicity, we make an assumption that this scale, one of the scale is along the motion. Assumption is one of the scale is along the motion. So it becomes one dimension. Do you get my point, right? So we could say that this whole movement is kind of like this. Let me redraw this now. So we're talking about everything along this line. So that becomes one dimension. So we are saying that the journey takes place from home to, let's say, school. So that is the journey in which the person is walking like this. So the person walks all the way, right? So it kind of stops here. This is a movement kind of stops and then continues. So we are saying that the person is walking along one of the scale which is time for us. So what we can do on the scale is we can only write distance. That is to say, we'll write d equals to, at this time, we'll write d equals to 500. And, so d is 300. Let's say this is 300. So we say 300. And then this time is along the axis, time moves forward. And then we again say that here also d equals to 300. So we are just writing d, the distance. And at this time, we are saying d equals to 500. And all this distance is in meters. So that becomes a motion in a straight line with time. You get an idea. So that becomes one-dimensional displacement. So in most of our examples in this particular video, we'll consider one-dimensional displacement where the axis time is, think about kind of like in the same direction. You get an idea, right? We cannot stop time, but we can say, well, the distance remains same. So here we are only saying that one dimension is distance in meters. You get an idea, right? So we have limited ourselves at scalar quantities so far by using the word distance. To get to vector quantities, we'll just change few terms. We'll use the terms like change in position, which will relate to displacement, which will relate to velocity. Direction being home to school. Does it make sense? So the whole 2D diagram could be represented now in 1D. And that is as if there is a motion sensor here and a person is walking away from it. Do you see that? If the person returns, it will return along the same path. So that is how we take care of one dimension. So I hope that part has taken care of a big confusion which I used to have. So we'll always talk about, in this particular video, straight line movement in direction which is along our time axis. You see that? Okay. So we are measuring the distance only. Since we are measuring only distance, it becomes one dimensional, right? So let me rewrite here. Since only d is measured along t, so along t is fixed, along t, it is one dimension, right? So we'll keep this concept in mind as we move forward. So I hope that is clear, right? Now let me take an example to illustrate what we have learned. Toronto to Niagara Falls is approximately 150 kilometers. Anil covered this distance in 90 minutes and returned in 120 minutes. Find his average velocity. We say assume, this is important, assume one-dimensional motion, right? So I hope you've got the concept, one-dimensional motion. For going to Niagara Falls, for return trip, and for total trip. So let me first sketch this one-dimensional motion here. So it is along this path, do you see? We have aligned the path along the motion. So think like this. that the movement is from Toronto to Niagara Falls. And the total distance is, we'll say this as 0, initial point, and the final point is 150 kilometers. We are not getting into details, but we're talking about overall. So whenever we say overall, we are talking about average. Right? And time taken t for all this is different while going and while coming. So we have two parts to this. We need to find average velocity. So when we say average velocity, we are keeping direction in mind. So going to Niagara Falls, that is the direction, correct? So let's do it in one by one. A, we will find average velocity to Niagara. Now, since it is going away, we'll treat this as positive. So it is treated as positive. As from the starting point, it is increasing. Do you see that? Away. So that is another nomenclature. So average velocity is change in position over change in time. Now in our case, we'll take the change in position as positive since it is increasing. So we'll say this is 150 kilometers. And he took how much time? So he covered this distance in 90 minutes. So we'll divide by 90 minutes. 90 minutes is 1.5 hours. So I could also write this as 150 kilometers, 1.5 hours. Right? So dividing this, we get 100 kilometers per hour. So that becomes the velocity since we have given the direction, correct? It is going away. So I hope that part is clear. Let's do part B. We could write this also as velocity in vector, right? Average velocity. So that is the short way which we are going to use soon, is actually now equals to change in position. So over change in time. In this case, change in position is again same, which is 150. However, it will be treated as negative since it is returning, right? So it is returning. So distances away will be positive, decreasing will be returning, so it is going to be negative, right? So from a fixed point, let's say this is the fixed point, you could also write this as final minus initial. Do you see that? You could also treat this as 0 minus 150, which is, let me write here, final position, and this is initial position. Now at Niagara, you are 150 kilometers away, this being the reference. So in all physics problems, we have to work with our reference point. In this point, reference is here, which is Toronto in this case, T, Niagara N. So return will be final position 0 minus initial position will give us minus 150 times the scalar quantity, which in this case is 120 minutes. 120 minutes means 2 hours, correct? So it will be minus 150 over 2 kilometers per hour. So that could be written as minus 75 kilometers per hour. you could compare a bit slower. But this is average velocity, and this is from Niagara to Toronto. So that becomes the average velocity from Niagara to Toronto, minus 75 kilometers per hour. So I hope that is very clear, right? Now let's do part C. Now part C is total trip. So total trip will be, you started from Toronto, that is Toronto to Toronto. So that displacement we are looking for. Time taken is, you can add these two, right? Which is 90 plus 120 in minutes, for example. Now this total distance is 0. 0 over whatever, in this case 210 minutes, will give us 0. So the overall average velocity for this trip is 0 kilometers per hour. Do you get that part? Since the position doesn't change, you start from here and end there. So it becomes 0. Now, if the same question would have been for speed, then average speed will be not that. Do you understand? So average speed will be greater than 0 in this case, not 0. Perfect. Since the total distance will be 300 divided by total time, which in hours will be 2 plus 1.5, which is 3.5 hours, right? That is going to be average speed. So from this particular example, you understand few concepts. That is, average speed could be different from average velocity. In spite of making a trip or a journey, you may have average velocity as 0. Velocity is a scalar, velocity is a vector quantity which will have direction. Speed is a scalar quantity. Most of the motions which we are considering now are assumed to be in one dimension, linear, in a straight line, as we discussed, right? So I hope that makes some sense. Now in the next video, we'll take up some more cases where we'll see how speeding and slowing down affects the calculations. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.